Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 8. Today we're going to learn about silhouette in machine learning. This will be the topic. The silhouette score in the content of the machine learning is a method for the evaluating the quality of clustering result, the quantifying how well each data point fit into a assigned clusters compared to other clusters. Essentially, it measures how cohesive and well separated the clustering is one of the unsupervised learning method. First, we explain what the silhouette values meaning measures and how they calculate and interpret them. Then we show how to determine the number of clustering using the mean of silhouette values. So here we can here's a breakdown. So we have cohesions, how similar data points. Okay, so for the first, we want to explain about this little bit. So the silhouette score in this context of machine learning is a matrix used to evaluate the quality of cluster or clustering results in the quantifying how well each data points fit into assigned clusters, right? So comparing the clusters essentially, right? So clustering and unsupervised learning. Okay, clustering is a type of unsupervised learning method. This is mean that unlike the supervised learning, there is no predefined label categories for the data. Okay, so here we can say there are no predefined label categories for the data. The goal of the clustering into the group similar data points is together. Okay, so the similar data points together cluster based on the inherent properties, right? So how Solute is used? So the text outline to main applications of Solute values, so measuring and interpreting. So the Solute values for a single data points measure its similarity to its own cluster compared to the similar or other clusters values. Okay. So the range from the -1 to 1. So a value close to the +1 indicates that the data point is well matched to reach over our own clusters and poorly matched to the neighboring clusters. So a value close to the 0 indicates that the data points in on very close to the decision boundaries between the two neighboring clusters. A value is close to the -1 indicates the data points to assign it the a wrong cluster. So let's determine it. So we have a cohesion, how similar data points is to other points within the own cluster. So we have separations, how different data points is per point into other neighboring clusters. So we have solute score. So the score is calculated for the each data point and the range from -1 to +1. Okay, so a score near +1 indicates the data point is well clustered for a other clusters, right? So here we describe that indicates that the data point is well matched to its own cluster and poorly matched to the neighboring clusters, right? So a score 0 indicates that a point is close to the decision boundaries between the clusters. So a value close to the 0 indicates that the data points on the way or on or very close to the decision boundaries between the two neighboring clusters. So if score is negative suggested, the point may be assigned to the wrong cluster. So a value close to the -1 indicates that the data points likely assigned to the wrong cluster. So it's the determination of the numbers. The y means schedule score values. Okay, optimizing the number of clusters of the data sets by calculating the mean schedule score like difference. Okay, by using the cluster of KML. Okay. So we have the cohesion. So about the cohesion is nothing but this measures the how the similar data points is to the point within the own clusters. High cohesion means the points of a cluster are close to the each other. Separation means this is a mean how different data points from that point of in others. Okay, neighboring clusters. High separation means the cluster or distinct and do not close to the each other. Right. Okay. So this is the actual point of the theory. Now, come to the certitude values. The certitude value is a combination of the scores, cohesion and separation. Cohesion is a measure the similarly of the points in the same cluster, so we can call it an intra-cluster matrix. So, certitude value is a combination of two scores, cohesion and separation, right? So, this is a fundamental principle of a certitude. Certitude values is not a single measure. It is a result of comparing how well a point fit within a cluster, various in how different in a form of other clusters, right? So when it comes to the cohesion, so cohesion is a measure to the similarity of the points in the same cluster. It also referred an intra-cluster matrix. So the prefix intra means within so an extra like intra cluster matrix evolution the properties of the points and inside a single cluster. High cohesion means the points are the tightly packed in a similar each data points or each other's. So it is a point of cohesion. So it is a calculation method. So we use this formula. Okay, cohesion means the similarity of the points in the same cluster. So we can call it as an intra-cluster matrix. Let C be a cluster and the xi xj is C2 points into them. So then we can interpret the distance between them, a measure of the similarities from there. Okay, we define the cohesion of the point of xi in its cluster C, and it means distance between xi and the point of the xi xj in C. So it is a formula a equal to mean. So we can use this formula to estimate that values to measure it. Let's come to the separation. So on the other hand, separation refers the degree to the which the cluster do not overlap. So it's not an intercluster matrix. So initially, the distance between the clusters speaks about the goodness, the separation. So we define the separation. So x of ECI has the minimum mean distance between the xi and the cluster. So we use this formula for it. So then we can say that then the certitude value of the point x is. So this is the calculation. It's the range in -1 or +1. The higher the certitude values, the more certain we can be is its labeled is corrected. Okay, the high mean certitude value of all the points indicates a good clustering. So based on the this topic, separation of the calculation of certitude value, so we can say that separation refers to the degree to the which clusters do not overlap. It is an intercluster matrix, meaning it measures the properties between the different clusters. Initially, the greater than the distance between the clusters, the separations, the separates of the data points xi and the cluster ci is defined to the another cluster. So it's minimize the mean distance between the values of the all data points, and any cluster can be formula. So this finds the distance between the point and all the point of the each neighbors. Okay, so it representing the distance of the closest neighbor cluster. So when it comes to certitude values, the certitude values for the point of xi denotes to the si. So it's majorly like seems like has the SI or the SI is calculated using that combination of the cohesion of AI, okay, and separation of PI. So we using the calculations part. So overall, the conclusion is the range of the solute value is a -1 or +1. The higher the solution value, the from the point or solute value, the more certain we can be label it. Okay, so it is correct. This is because high value implies that the point must closer to the point closer to the points. Okay, so a point is much closer to the points in its own clusters than it is point to in another cluster. Okay, for the large, a high mean simulation value for the all points indicate the good overlapping clusters, result where the cluster or well separated in the cohesions. So we have a how to calculate the certitude values. So we have a cluster A, cluster B, cluster C. So we have some range of values here. So this is the formalization. Pause the video and note this formula. Okay. So like this, we can calculate the distance. Okay. And we can see that we can compute the mean of the distance between the points of the cluster B and same way. And following the same step, we computed mean difference distance to the cluster C. So the separation of the score, like we calculated. So here we have analyzing the certitude values. So let's say we have two clusters A and B, but such that B is a cluster closer to the A. We're calculating certitude values of a point in A. So certitude values Si of any point A will be closer to the one, and B is greater than AI, right? So we can see here we have a cluster. So it is a certitude value of Si. Okay, here the green is the triangle. So it is a value of the certitude. Okay. So like this, the cluster parts will be divided by each data groups. So therefore, as the average of the certitude values of the points in the cluster gets closer to the one, cohesion and the separation of the cluster has a real increases, right? So the conversion is also true when the certitude value is closer to the zero, but AI and the BI points are the similar to the distance, right? So between XI and the elements of the A and B. So like the differential in the say data. So here we can see the worst case of occur when the substitute values of S. So it negative, which happens when A is greater than the BI. Then the point of the question lies closer to the B. So A. So look in the modification. So we can see here. So it has a classified here. So hence as the overall solution, hence has the SI value decreases the quality of the separation. Detroit and the quality of the clustering gets worse. So we have scheduled plots. So we can see here. So based on the data, we have a scheduled plot is a visualization tool. We can say that. So the tool that helps to evaluating the quality of the clustering results, the visualization of scheduled values for SI for all the data points in the clustering, right? So data point and the clustering. We have some examples like the plot shows the scheduled values of the clusters. The cluster or the typically arranged in a random or order or blank space instead of between the closure and the cluster to make the visualization distinct. Okay. So start sorting, we have sorting within the clusters to individual the value of the data points. Sorted decreasing order that makes it easy to see the range of the secret values within the clusters. Okay, identifying the point in the low score. So here the overall the example is that the image shows an example using k-mean, right? So clustering algorithm on the two-dimensional data sets resulting in a four clusters. Yes. So we can say that the left plot of the certitude and the right plot of the shows the clusters themselves. You can see the how the different certitude values in the left point. So the corresponding of the cluster shows the right. For instance, the black cluster on the right has the black cluster. This is the black. The black cluster of the right hand or has the many data points. They are poorly clustered, extending a negative values, while the green clusters has the higher simulation or higher security values. So according to the data. So like we see the choosing the numbers. So we have the according to the data points, we have the higher number here, ticket blue and yellow, second black and third yellow. So according to the data points, we arrange 1, 2, 0, right? Okay. So like we see the data. So we have some more examples here. So let's see here. So here we can see the right cluster remains intact while the left one is split into a two smaller ones. So there are the clusters we have situated values in the one obtained by the blue cluster, but all the three appears into the but well defined, right? So what happened if we use k equal to 4? The average certitude value drops the slightly to 0.74. So it use. So here we see the green and the black clusters have better certitude saturated than the two other two. Okay. So it probably because the points are better separated than the points of the other two clusters. Finally, the average certitude values for the k equal to 5 drops the 0.66 and the 0.53. So the similar data points. So we can see the difference between the data points. So finally, so k equal to 2, 3, 4. So appears to be group choice for the has a k equal to 5 and the k equal to 6, given the lower quality of the clusters. Yes. So interpret the meaning. Certitude values measures the relationship between the clusters, cohesion and clusters, right? Separation. So the meaning of the certitude values presented the balance of an overall cohesion and the separation in all clusters. As we all concluded the previously, the cohesion and separation of the clusters are better than when the certitude values are closest to the one, right? Therefore, we are looking for the cluster within the higher mean certitude values to identify the close to one. So here's the mean of the k, right? 2, 3, 4, 5, 6. We got the above example. So we have the exact certitude score of those values, right? So considering the gradation applicable, acceptable solution or those within the 2, 3, and 4 clusters in the best or this particularly simulation is the used for the data forms. Okay. So it's the overall the clusters. So about the conclusion in this tutorial, we learn about the certitude plots and the value. Okay. So, a certitude plot is a graphical tool we use to evaluate the quality of the clusters. Then the certitude value shows the degree of the cohesion and the separation of the clusters, right? So, we see the difference between the separations. So, the mean of the certitude values allows to identify how many clusters appears in the dataset. Okay, to check the how many datasets available, it is the best cluster and which is the um, least certitude cluster. We want to identifying the data. So, this is for this section. So, I hope you guys all are understand about this topic. Thank you.